right. Hello, everybody. We're going to kick off a couple minutes early tonight just to kind of get going. I hope everybody is well. Welcome to the stream. Tonight we have a lot of stuff to get through as well. So we will do that as quickly and efficiently as possible. Before we jump too much into things, though, I do want to take a quick second and thank the supporters of the channel, beginning with the partners. So those are the highest tier of support in Patreon and YouTube. And those would be Aerosio, Gerboles Inc., Patrick Coolman, and Wen Chang. I'd also like to thank all the other supporters on the screen here, who are the other tiers on Patreon and YouTube, as well as our Twitch subscribers. Thank you guys very much for your support. I greatly appreciate it. Of course, that goes without saying that I appreciate all of the folks who tune in here on Twitch as well as on YouTube. Without you guys, none of this would be possible. So thank you very much for your support and for following along with the project. So, tonight we are going to finish off the viewports. You can see here that I've actually got a pull request open. And what I've done is I've gone ahead and taken the liberty of implementing most of this off camera, simply because there were a lot of unknowns and I wasn't sure how many things I was going to run into. And I kind of wanted to get ahead of it a little bit. So what we're going to do, at least for tonight, is we're going to start by reviewing the changes that I've made here. I've got a number of changes that have been made, and after that we're going to kind of discuss why I made some of the decisions that I made. In fact, I think we're probably going to actually start with talking about what was done, right? So what we've wanted up to this point is we've been working towards the process of having more than one viewport. So if you can imagine that this whole sort of space here is our window, then we would have, a viewport, say, here, right? Note that this is not to scale, right? But it should give you guys an idea of what we're talking about. So the goal is to have two viewports, right? And both of those basically should be able to render a scene. So you'll have what we'll call viewport A and viewport B. And there's several ways that we could go about doing this. We could basically draw all of the objects in viewport A, and then essentially finish up that queue and draw all the things in viewport B, right? Or we could draw an object in viewport A, then draw an object in viewport B, that same object rather, and then draw another object in viewport A and draw that same object in viewport B. That's another way that we could handle it. And each of these basically presents its own set of challenges, right? So if I clear here, essentially the way that this works is we have I guess I'll use the text tool for this. Let me see, crank the font size up a little bit. So we have basically like there we go, like a begin frame, right? And that basically clears the screen, and it goes through and starts off the queue, right? So we have begin frame, we start recording to a command buffer, right? And then we load our global uniforms, right? Then we load our instance uniforms and load our local uniforms. Then we draw, right? And so this whole section in here is basically per object, right? So we have that per object. And then down here, finally, when we get to the end of that, we present, right? And that's sort of been our a very high level overview of what we're doing so far, right? And so this is fine when you have a single viewport, right? But it's a little bit impossible to work with this directly as is with a second viewport, because you can't just take this process and do it again, right? Because all of this, I should say, there's actually one step in here that I forgot, which is submit to queue, right? So well, I guess I could put end recording too, right? Right, I'll be a little bit more granular with this. And so we begin the frame, we'll say clear, right? We start recording, we do all of our globals, and then we do our instance, local, and draw. We end the recording, we submit to the queue. Once that is that queue finishes up, we go ahead and present the frame to the screen. In order to do this on more than one viewport, we would basically need to repeat this set of steps right here. And essentially, well, I should say, really what we need to repeat is this set of steps, right? Because each viewport might have a different camera. So one viewport might be perspective, whereas another is orthographic, right? Or maybe it's just two camera angles, who knows, right? It could be anything. It needs to be configurable, it needs to be able to handle this. And so we need to be able to repeat these steps. Essentially, this is basically rendering the world, right? And we need to be able to repeat this set of things more than once. The problem is you have descriptor sets for each of these things, right? There's a descriptor set for the global uniforms, and then for each one of these things here, right? Let's see. Argix2, thank you so much for the follow. I appreciate it. So the problem is you can only update these uniforms once per frame, right? And the only time that you can update it again after it's been bound is once you have ended the recording and submitted it to a queue. And then you restart the command buffer, and then you can do these things again. Our current renderer setup only has a single queue and only has a begin frame and an end frame, which basically does this step, and this step, right? So these things are our end frame. And in fact, let me draw this out a little bit, right? So this right here, do I need to layer? This right here is our begin. I really need to find my tablet, right? Sorry for my terrible handwriting, right? And then this is the end of the frame, right? So end. All right. And so in order to make this work the way that we need to be able to repeat these steps right here. In order to do that, we need to be able to also do these things independently, right? All these steps here. And so in order to do that, we're going to actually have to split up begin and end, right? And so begin and end are actually going to be going away in our renderer, and we're going to have a little bit more granular control over these things. And it's going to be a little bit more stateful, we should say, right? A little bit more kind of closer to like an immediate mode is what you might expect, right? Argix2, thank you so much for the tier 1 subscription. I appreciate that. Thank you very much. Appreciate the support. New account. What's up? Well, new account. Awesome. Welcome. I appreciate it. So basically, we've got some rendering refactoring to do, right? And it's not huge. It's really just changing our interface and kind of moving some code around. And then what we're going to do is we're going to support basically doing this, and this more than once, right? And that's going to be the first type of multiple viewports that we're going to implement. And then we're going to basically place the application to be in charge of how these things get called, right? And the second mode that we sort of talked about, where we draw an object in viewport A and then draw that same object in viewport B, that's going to be a second type of support that we also are going to add, although not in this change set. And we are going to be adding that because we want to be able to support both ways of working, right? Because our application, our game application might have different requirements than an editor might, for example, right? So we want to be flexible and be able to support both ways of doing things. So we're going to implement the draw one viewport and then draw the other first, and then later on we will do the second. So that includes all of the changes that we need to make to our renderer for this. The other thing that I wanted to bring up is we are going to be changing the way that our view system works yet again. And that is to say that we are going to take away the control from the view system as to the looping order or the order that those views get called in. Because there are times where we may want to render more than one viewport, but maybe not all of the views, right? And so we need to change that up a little bit as well. And so our application is actually going to be changing at the engine level a little bit as well. I've also done a couple of minor updates in here. I did add some coloring to the build scripts just to kind of indicate success or failure a little bit clearer. So if we actually go to... Do I still have my... Yeah, I do. So if I build debug now, we can see that we have the green text right there, right? Just kind of makes it a little bit easier to see. I did not make that change actually on the Windows scripts yet, but the Linux and Mac scripts have those. So that's that. And there's not really anything else to say on that. We actually have a lot of files changed here, right? And so I'm going to kind of go through these at a very high level and just dip into the functionality kind of where we need to along the way, right? Okay. Another thing that I identified that you'll actually see here, I've actually removed the render view skybox is because I determined we don't actually need a separate view for that. We can actually handle that within the world view. So I've actually taken the skybox view and gotten rid of it, and that is now part of the world view. So we'll go into that as well. All right. So I think probably the best place to begin is going to be the viewport itself. Now we already kind of looked at this in the last stream, but we'll go ahead and take a quick look at it again. I don't think there's anything too surprising here. I can't remember if we had this stuff implemented in the last stream or not. But basically all the viewport does for right now is it holds a 2D rectangle of the actual dimensions of the viewport, the FOV, the near clip, the far clip, the projection matrix type, which is either orthographic or projection, and then the projection matrix itself, right? And then whenever we call resize on the viewport itself, we'll go ahead and regenerate the projection matrix. So this is basically all this code does behind the scenes. We have this regenerate projection matrix that basically says, hey, for the given type, either call mat for perspective or orthographic, right? And if for some reason some other type was assigned here or no type at all, we're just going to fall back to perspective. And that's really it, right? There's not a whole lot else to really go over here. So that's really all the viewport is. It's a super light object, right? I guess the next thing that I could go ahead and touch on is we did add a couple of small things to a new file, a new geometry2d.h. And so I do want to point out here that I've gone ahead and used include guards in favor of pragma once, just because pragma once really isn't like a standard thing, and I actually kind of want to get away from using that. And so at some point I'm probably just going to go through the whole code base and change it to use these, just because that is kind of the more standard way to do it. instead of using Pragma ones, right? So with this, basically we have just a couple of quick methods here, only one of which is actually used for right now, but I stuck the second one in there just in case, which is a quick point in 2D rectangle check. So what we're also going to do is we're also going to implement a check to see, hey, are we within the bounds of a viewport on the screen when we're actually clicking, right? And we're going to apply that to the logic that we have in our application for our raycasts, right? So we're actually only going to perform those raycasts if we are inside one of the specific viewports, and we're not going to do it otherwise, right? So that would make sense, you know, if you're in an application that has multiple viewports, you should only really do it on the one that you have focused instead of like from the UI or something like that, right? Naha, thank you so much for the follow. I appreciate it. So that is what that check is for. And then we just have a new circle TD structure here with a center and radius and a point and circle, right? Alexander Gambit, thank you so much for the follow. I appreciate it. So that is it really just for that that new geometry 2D. We're going to be adding a lot more to that, but those are just kind of the things we're going to need right away. The other thing, I think application types mostly, that's mostly the interface changes. So I'm actually going to come back to that one. See if I can start collapsing some of this stuff. So I think probably the best place to start is going to actually be the engine. Because that is kind of where some of these changes are taking place. So these are all just include sorts, right? We haven't actually touched engine.c in quite some time. So we've actually changed the linter that's being used since then. Since the last time this file was touched, we haven't touched it in forever. So that's why it is where it is. And so basically, the engine here is going to call the application's new prepare render packet, right? And so the interface changes. Let's see. You know what? Let's actually go to render types, right? Because that's actually going to make this a little bit easier to explain. So the render types, this is our renderer plugin structure, right? So this is what the backend hooks into. We have a RWXC99. Thank you so much for the follow. I appreciate that. So we have a frame prepare here, which is sort of the replacement for frame begin that we had before. So the concept of begin and end frame is going away. And so this is the basically only now handles the routines that are necessary to actually begin a frame. So basically what this does is it goes ahead and starts up the recording of the command buffer by default. And it goes ahead and I want to say it also performs the clear. I have to double check on that. But the important part is that the begin can also now be called separately. So begin is actually what kicks off the recording process of a command buffer. So this is now just a call to begin instead of begin frame. It just calls this guy, right? And then you would do all this other stuff, right? And then you would end recording, which is just an end call, right? So that is, where's it? Right here, right? So end basically just ends the recording of the current command buffer. And then we have a separate present state, right? And the reason that we separated all this out is because we can now say, okay, frame prepare, and then we'll set the active viewport, and then we'll say, okay, begin, and then we'll draw all the things that viewport needs, and then we'll say end, and then we'll change viewports, and we'll say begin again, and do all the things that it needs, and then we'll say end, and then we can say present, right? And that's how we're going to accomplish that. Is Pragma once a Microsoft thing? I don't think so. I think it's just an extension that a lot of C compilers support, but it's an extension. It's not like core C. Like GCC and Clang support it too. which is Clang is what I'm using, by the way. So. Do you know that GeoHots guy? That name rings a bell, and I don't know why. I'm not sure. I don't remember why that name rings a bell, but it does. Oh, yes, the PS3 jailbreak guy who went to jail. Yes. Yeah, now I know who you're talking about. Yeah. He streams on Twitch? Really? I didn't realize he was active again. I knew that name sounded familiar. Yeah, he is. Super smart dude. Okay. So, I think that is predominantly the changes that are actually made in render types. The other thing we did was we moved Skybox packet data to this here as well, so that we had more generic access to it. And all the packet data right now holds is just a pointer to a Skybox, right? The render view packet also got some changes. So it now takes a pointer to the viewport that is going to be used to render that particular view, right? And also it has the Skybox packet data added to it, right? So the other, if I can expand this, let's see. Where did it, why did it put me all the way back up there? Okay. So if you recall, we already have the terrain geometries, we already have the debug geometries, we already have the regular geometries themselves. Now we have the Skybox data that we can use to handle all of this in one render view packet, right? And if we don't wind up using those things for every render view, which we don't, that's fine. We just leave them as null pointers, right? Oh, okay, that's actually all we did. We moved this up. We didn't move it from a different file. We just moved it up, right? So it was all the way down here at the bottom, and because we're using it here, we had to put it above render view packet, right? So that is the changes to the interface. It's not a crazy amount of changes, but it was enough changes where the interface changed quite a bit, right? The other thing is we'll take a look at the renderer front end to kind of make this a little bit more clear. So initially, the renderer front end just had this single renderer draw frame call, right? And that was what the engine called. It just called draw frame, and then the back end, you know, it sort of split it up into the front end, the back end, and handling the begin, the end, and all that. And now we've actually made the front end expose a lot more of that back end technology, or back end calls and stuff like that, so that we can be a lot more flexible from the application's perspective and not have the engine be so deterministic on how the thing actually runs, right? So we have the renderer frame prepare, right, which basically just prepares, and then we pass a pointer to the frame data, right? We have the render begin, which is just that begin call. We have the render end, which is just that end call that I mentioned before, and then we have present, right? So it's just 4 individual steps now, instead of just one on the render front end. We also have the concept of an active viewport in the render, so that we can get a pointer to that if we actually need it. So we can set and get that anytime we need that, right? So that is that. And that's basically the interface changes, right? There's, like I said, it's not a lot. It's mostly just kind of moving code around. So if we take a look at the front end C file, CK41N, thank you so much for the follow. I appreciate it. Let me see. I've only ever used GCC. Is there substantial difference with Clang? I've noticed Clang seems to compile a little bit faster, and it's got a lot of, it supports a lot of extensions, like Visual Studio extensions and stuff if you're compiling on Windows, which is pretty nice. Your current facial hair reminds me of the programmer meme about job hunting. That's hilarious because this actually came up in a stream I was watching the other day. When you're not job hunting, you look like... scrolled. When you're not job hunting, you look like a hobo. When you're looking for a job, you dress like a businessman. Not calling you a hobo, it's just a meme. I mean, this time last year, I had a beard that was like down to here. And I'm actually working on growing it back out. So yes, hobo look for life. I'm like that meme. Yeah, exactly. Yep. And I will be that meme once again. Kate Moy. I hope I'm pronouncing that right. Hey man, I just watched some of your vids on YouTube. They're really good. Thanks for sharing that. Yeah, thank you for letting me know. I appreciate that feedback very much. Thank you. And welcome. So, on the front end, we basically have just implemented those interface changes, right? So we do now in the renderer system state hold a pointer to the active viewport that we set in those get and set. The renderer frame prepare now holds two different things, right? So before we had a frame number, now we have a draw index. And you'll see this draw index pop up multiple times. So what the draw index is it basically represents, I guess I can use red. The draw index represents one of these cycles, right? So that is our draw index. Whereas the frame number represents, I'll go with, I guess, let's go with yellow. So the frame index represents this cycle, right? So that's the difference there. So the front end now maintains a draw index. Of course, it's actually stored at the plugin level, or the plugin interface level, I should say. So basically, when we prepare, we go ahead and we increment the frame number, but we reset the draw index back to 0, right? And then we do all of our logic that we were doing in the frame begin and all that stuff. We do all of that same logic here. It's just kind of moved around a little bit. So instead of calling plugin frame begin, we call plugin frame prepare, right? And this is almost, frame prepare is almost a drop-in replacement for frame begin. We go ahead and we grab the attachment index here. We set the p frame data's render frame number and draw index, and then also the render target index, which is for which frame in flight we're actually on, right? So, and then we go ahead and just return the result of this, right? So that is all that frame prepare does now. If we look at render begin literally just is a pass through to plugin begin, right? Render end is again a pass through to plugin end, but it also increments that draw index, and then goes ahead and syncs the frame data's draw index to that number, and then returns the result, right? So that's where we keep that synchronization. And then the renderer present is literally just a pass through to the plugins present, which is like where the front and back buffer gets swapped. And we are ads. Let me break for ads real quick. Got about 45 seconds left on ads. So for any of you that can hear me, I try to interrupt the stream or, not keep going with my explanations when ads are playing, because I don't want anybody to miss things, right? So I've found it's much better to just sort of take a break here while ads are running, and then I'll get back to the content. And we got about 10 seconds left. Cool. All right, so we are back from ads. So, Smudge, good evening, welcome. Meanwhile, me, a European, enjoying this literally at 4 a.m. Yeah, I wish I could stream at a different time, but unfortunately this is the only time I have. Should have capitalized that AM. Yeah. It is late over there for sure. Hopefully you don't have to get up early. Or maybe you already are up early. Let's see. We left off at present. The other thing that we've done is in our render passes, we've removed the concept of render areas because we can now extract that from the viewport itself. So you're going to see some changes regarding that as well. Here is our active viewport set. So all this does is basically get a state pointer, sets the active viewport to the one that's passed in. And then we go ahead and we calculate a viewport rectangle off of that using the same height, negative height, X and Y that we are using for our initial viewport. Just now it's calculated instead of hard-coded. And then we go ahead and we call plugin viewport set on that. And we also set our scissor to match that same viewport dimension, right? So that we are discarding pixels outside of that, and we don't actually affect any of that, right? Oh, you're on vacation. Perfect. So the other one is obviously the getter for that, right? No further explanation needed. So that is the renderer changes in a nutshell, right? Really quickly, also, I did make some small updates to math types. So in our vector 4, where we have our union, right? So our X, Y, Z, and W. For Z and W, I added width and height, respectively, just because we also have type deft let's see, where was that? I thought that was in here. Yeah, here it is. We've also type deft the vector 4 as a rect2d, right? So there's no sense in writing a separate structure for that. We already have a structure for that. We can use that with a lot of different things. We just kind of added these to make it a little bit more explicit in code, right? So that was another change that we made, just a minor thing there. We are done with the renderer. And actually, we'll just touch on some math stuff and we'll knock that out real quick as well. So, Katamoy, thank you so much for the follow. I appreciate it. In Kmath, we just added a quick vector 2 distance squared. For some reason, we had this for vector 3. We didn't have it for vector 2. And then this is actually just used for the radius check on the 2D circle, right? So that's what that's for. And then our geometry 3D, we had to make a small tweak to our ray from screen. So we now base that off of the viewport rectangle instead of the screen position and the viewport size, because we're not always going to be starting at 0, 0 up in the corner, right? We could be starting anywhere on the screen. So we need to take that full rectangle into account, and that is what we do here, right? And we basically, instead of just dividing by the viewport size, we take the screen position minus X, or screen position X minus viewport rect X, and then work that in and divide by the rect width, right? And then we do the same thing for the Y dimension, right? So we just take that into account there. And I think that is actually it for the math stuff too, so we can collapse that. And actually, if we go over this frame data stuff, we can collapse this too. So frame data, we've just, we added the render frame number to this. I'm not sure why it wasn't there, but we were kind of passing it around in some functions just as a parameter, where we were also passing frame data, which didn't make a whole lot of sense. So what we've done is we've gone ahead and just added this to our frame data since we're passing that around anyway. And then we added our draw index as well as our render target index, because that was another thing that was being passed around. And so our frame data just reflects that. We've already gone over these engine changes, so let me minimize that. The application types. We've exposed a couple things from the application, so we'll just touch on that really quickly. Most of this is actually formatting stuff, so we'll skip that. So the application used to just have a render function, and now the application actually has a prepare render packet function separate from its render function. So the application used to, within the render function, it would build all the render packet and then also do all the rendering. And that was just kind of all in one step, and it really shouldn't have been. It should have been split out. And so that is 2 separate steps now, and that allows us to handle the way that the packets actually get handled within rendering much better. So we'll go into that once we actually get into the testbed code, right? So that is that. May I ask, why did you choose to develop your engine in C and not C++? And why not Rust? Well, I haven't used Rust enough to be able to have an opinion on that. And I would certainly not try to write a game engine in a language I don't feel very, very confident and comfortable with. So, C++, I programmed in C++ for a lot of years, but I found more often than not, I was leaning more towards a C style of programming for almost all things. I don't use the STL at all. I don't use templates. I don't use classes. I don't use inheritance. I don't use object-oriented programming. I don't use function overloads. I don't use operator overloads. The only thing that I kind of on occasion miss is operator overloads for like vector multiplication, things like that, but it wasn't enough to make me want to switch. C is a much simpler, much cleaner language to work with. It compiles faster. It's just a hell of a lot easier to use, in my opinion. Rust is great, but I do not wish for Travis to fall into the lifetime hell. Yeah, it does some interesting things with memory and borrow checking and stuff like that. I've read up on it a little bit, but I just honestly haven't used it enough to formulate a full opinion. I've seen it described as C is simple but unsafe, Rust is complicated but safe, and C++ is complicated and unsafe. Yes, but Rust is only... There is a unsafe keyword in Rust that you sometimes have to use with things. So, I don't know. I don't like other things telling me how to manage my memory. I want to manage my own memory. Dang it. I find it very hard to work without classes. I've made quite a lot of progress in my game at the moment, and without classes, I feel like I would have been impossible. Object-oriented programming, that mindset is very hard to break out of once you're in there. I still find myself every once in a while slipping back into it. And I find more often than not, it gets in the way. All languages have support structs. Wait, all languages that support structs have OOP. That is only if you don't have inheritance. Yeah, so I mean, we can do OOP and C if we wanted to, but why? Yeah, I'm not a fan of OOP. It gets in the way. And for things like memory fragmentation, it's awful, right? Not that I'm saying we don't have memory fragmentation issues in this engine, because we do, and we're going to eventually have to fix those things, but staying away from OOP will make that a lot easier. Okay. All right, so the other thing that we had to do was in the material struct, we had render frame number being tracked before. And incidentally, for some reason, that was a U32 when render frame number is a U64. So that would have been a nasty overflow bug if the engine ran long enough. So I went ahead and fixed that. And then I went ahead and added the draw index as a U64. It's actually implemented as a U8. But if I ever step it up to U64, this will keep me from running into an issue there. So basically, the render frame number and the render draw index are used to determine when a uniform needs to be updated, or when its descriptors need to be updated, right? Because you can only update it once per frame, once per draw, and we need to keep track of that. So that is why that is there. Let's see, and that is in resources. I think we've already done... Why Why did it sort it this way? Okay. Anyway, we'll touch on the skybox changes really quickly, which is basically just adding a draw index, right? This is an include sort, and I think that's actually it. So we add the draw index to determine when the skybox material needs to be updated, right? So there's that. UI text actually has the same update. So that has a draw index, and then we use that to determine when that should be updated. The material system was one of those things that was taking in... actually, we probably should refactor this to take frame data, right? So I may do that as a separate pull request. In fact, let me make a note of that. Frame data. So this is kind of one of the annoying things that's happened in a few places in the code base. I thought I got them all, but I apparently missed this one. So here, whenever we apply the globals, we are applying it with, and we pass the renderer frame number, the renderer draw index. We really don't need to be doing that, right? We can just pass the frame data and have both of those things. So it looks like all we did here was we just added to the frame number check, we also check the draw index, right? So that kept the change simple, but I think I'm going to wind up changing that, right? I'll do it in another pull request. I'm not going to... This one's big enough already. Let's see. Yeah, but the modern meta programming features in modern C++ is definitely nice, especially all the compile time features. Yeah, there are some nice things about C++ in terms of the compile time features, like the ability to like hash strings at compile time would be really nice, but again, it's not something I would ever use. I don't use templates either, so I know that's a big thing that a lot of people use. I don't use those. Straight arrays are much better. If that's the case, how do you do mage fireball.x goblin x goblin width equals do something? That's my way of using classes. How do you put that into code without the use of classes? I guess it's... Your code should really be looking at the... comparing the positions, right? It shouldn't care where those positions come from, right? The function that looks at those things shouldn't say, well, I'm taking a mage, or a mage's fireball, and a goblin, right? And let me grab the positions out of that and look at it, right? It should only be... The actual comparison function itself should just be comparing distances or against the radius or something like that, right? You don't actually need OOP for that. I love Rust and Zig for the metaprogramming. Yeah, I can't speak to either one of those. I haven't used them. I'd love to use Jai, but it's sadly still closed beta, and I ain't a famous programmer to get access. Yeah, I mean, Jai seems like it would be interesting, but again, I'm trying to build something that people can actually access and follow along with, so I can't use that. But he's doing some interesting things with Jai, for sure. Yeah, what you described is just structs and methods. You would just pass the struct as the first parameter of a method, which, yeah, you could do it that way too, although I would say you should break it into more parts than that. It should just be a positional check, right? And then whatever manages that thing, which would be your gameplay code, would just know where to get those things from. Okay, so... renderer view system is one of those things that we kind of have changed a little bit. So we have frame data being added to that. We took away this linear allocator that was being passed because that is actually part of the frame data as well. And so when we build the packet, we pass along the frame data and the struct viewport, right? And then we just call this method, right? This is actually one of the functions I'm going to be removing. This one and the onRender, because our gameplay code, or our game engine code, like our testbed code, has access to these views and owns the views. And it should really be up to the application to be managing that. So this system is, these changes are temporary, so it fits the interface without breaking things, but we're not actually going to use this code, and this system is probably going to wind up being removed completely, I think, because it's not actually doing all that much anymore. Yeah, the shader system, we just added something to the shader struct, right? Which is the draw index. So similar to our materials and everything else, the shader will also need to know these things for like globals and things like that, right? So that's the shader. Where is... I guess I minimized this a little bit too soon, didn't I? Yeah, so resources, systems, we've done that. Yeah, actually that is all the engine code. Okay, so that's all the engine code that's changed. Let's see. Hugvelts, I understand the confusion. I'd recommend trying to make some simple things in non-OOP language to see where the differences actually lie. 100%, yes. Start simple, and then, I mean, don't start writing something like a game engine without OOP if you're used to using OOP, right? Start small, write several small applications, and then try to write something bigger. For me, OOP is just a way of organizing code. A namespace is like a class in my mind. Kind of, sort of, yeah. Inheritance is something I rarely use. Yeah, I try to steer away from it these days. Inheritance is not really something, and I don't even really use composition all that much either anymore. A little bit, maybe. Maybe for something like an entity component system, if you even need that, which in most cases you actually don't. But yeah. Okay, so in the testbed source, in the entry.c, we actually had a couple of things that we needed to change. So this is just an include sort. But what we have here is we had that new prepare render packet function. So we need to load the function pointer for that. And then basically shove the index of all these down. This is another to-do I have to kind of work on. But since it's a testbed, I don't really care that the indices are hard-coded. But I do want to come up with something a little bit more robust for this. But yeah, that's just testbed code, so I'm not really worried about it. So the next thing is going to be, I guess, the views. Did we already tackle game state? I don't feel like we did. Let's tackle game state first. So the game state, which is obviously owned by the testbed, now has two viewports, right? So we have a world viewport, which was sort of our default viewport before. And now we have a UI viewport. And we have a second viewport down here, which is world viewport 2. So to put this in perspective, we have our entire window, right, which is this whole black area, right? That's, just imagine that's our window, right? So we have one viewport that looks like, again, not to scale, right? We have one viewport that looks like that, and that's world viewport number 1. And we have another one that looks like this, right? So that's viewport number 2. World viewport number 2. Yes, I know left to right they're backwards, but it doesn't really honestly matter. We could switch them easily at any point, and it would be a very simple thing to do. And then we have the UI viewport, which is a separate viewport that we render like the text and other controls on top of everything. And that viewport happens to line up with the whole screen, right? So we can very easily build our UI on top of our other viewports into the world and be able to position UI elements over and around those viewports and actually use the UI layer to control the size of viewports, things like that, right? So that is the viewport layout we're going with for our testbed, at least so far. What is the textbook use case for ECS? I've seen it described in almost always overkill. For indie games, yes, agree 100%, but I don't know it well enough to know why that is. So ECS basically gives you ultimate configurability, right? But there's sort of a sliding scale with configurability versus complexity in the application, right? The more configurable your stuff is, the more complex it is. And it allows you to very easily sort of click together components, be able to compile components together to make one thing, right? And that's all well and good, for being able to click stuff together in an editor and whatnot. But the problem with that is all of those entities typically are dynamically allocated, which means heavy memory fragmentation. And it's typically, like you said, for most small games, it's complete overkill. Like, when do you really need more than a mesh or a light or a sound node, like a 3-dimensional sound node or something like that, right? When do you need to really have those objects grouped together and configurable as separate components versus just kind of operating on their own, or maybe using the same transform, via a pointer or something like that, right? Like, generally speaking, you can make things a lot easier without all of that overhead. This is what I have so far. The grid is now working. What I need to implement next is an editor where I can add textures for each independent cell on click. So I assume that means it's a 2D engine. So you really don't need ECS for that. I don't think. Tammin, hello. Good evening. Welcome. Hope you're doing well. Is there a new Bevy tutorial course on YouTube that explains... Wait, there is a new Bevy tutorial course on YouTube that explains ECS pretty well. Can I share the link? Yeah, go for it. That's fine. Oh, you know what? I think my bot might be actually killing that. You know what? I would say go ahead into the hop on the Discord server and put it in the Kohi channel. That's probably going to be the best place to put it. I'm still figuring out my Nightbot, by the way, to make him like allow things, but I'm fairly new to streaming, so I haven't figured that out yet. But yeah, in terms of ECS, like I said, it's like 99% of the time it's 100% overkill. But yeah. It seems to be popular among people who don't need it. Yeah. Well, the reason it's popular, right, is because Unity uses it. And lots of people use Unity. And that's why it's popular. Developing an ECS is a nice experience, though. Yeah, but again, like, to give you an idea of how important I think ECS is for a game engine, like, Kohi is not going to have an ECS in its core. It just won't. ECS is going to be developed as a plugin for Kohi at some point down the road that you can use optionally, but we're going to have a way of building things without it, right? It's not going to be required. Totally optional. You learn a lot about data locality. Yeah, yeah, big time. And the thing to struggle with there is like, how granular do you go? Do you have a transform component, or do you have a position component, rotation component, a scale component, and then, also like a matrix component or a matrix system, I guess, that creates, you know what I mean? Like, you can go nuts with it. But yeah. So back to this. That is our 3 viewports, right? So right there, right? So that is the change to the game state. And then if we go ahead and look at the, we'll take a look at the editor view world so that we can knock this out, right? And all this is, I believe, is just the interface change. So we were taking the frame number and render target index, and now we take, that stuff's already present in the frame data. So we just got rid of those and repointed these, right? And I think that's literally the only, it isn't the only change. So the other thing that we do is the packet also has the viewport, so we also make sure that we set the active viewport, right? So we set that on whatever is passed in the packet. This is just a reassignment. We also check the frame number and the draw index here. So there's that. And then we sync the shaders, render frame number and draw index here as well, right? And then this is just the interface change for that view, right? So that most of the view changes are actually going to be that same basic set of changes. You're actually going to see it repeated a few times. The other thing to point out in this file is we have taken out of the internal data the FOV, near clip, far clip, and projection matrix because the view holds all those things. So we don't need to set defaults or any of that stuff. We're not doing any of this hard-coded matrix stuff in here anymore. That's all gone. The resize logic is also a heck of a lot simpler. So we don't do any of... Actually, we probably should have left this in there. That's gonna be a potential bug. Caught that. This is why you review your code, folks. So that should definitely be there. Okay, so I'll have to push that up before I merge this. So we don't need to calculate the aspect anymore, or the projection matrix, or any of that stuff. We also don't set the render area on the render pass anymore, because that doesn't exist. So we don't have to do any of this logic anymore in the resize. All we're basically doing is just keeping note, like, hey, we got a size update. That's it, right? And that's all the changes for that, right? So that is that view. I can close this down since we're done with that. Let's continue to the other views real fast. So I already mentioned that I got rid of Skybox, the Skybox view. So let's actually take a look at the render view world, because that is probably one of the bigger changes, right? So we're using the frame data now. We have the ads. Ads looks like lads. That's funny. Got another 20 seconds on ads. So we've added the include for the viewport and the skybox into the render view world. We now have the skybox shader locations here, so that's just for projection view and cube map location. We've added the skybox shader or pointer to that shader to the internal data. And then also we keep track of the shader locations. So when we first register the view, we go ahead and we call shader system create. And we're now doing it as the second pass, since the second pass is the world pass. So the way that we've reconfigured this is the first pass of the render view is the skybox pass, and the second pass is the world pass, right? So when we go ahead and create the this guy, I don't know why it scrolls me back to the top every time I extend it. So when we go ahead and create the material shader, we create that against render pass number 1 now instead of render pass 0, right? Then we load the skybox shader, right? And we create that against render pass 0, okay? We unload the resource for that. We go ahead and get a pointer to the shader as well as the locations of the projection, view, and cube texture. And then we go ahead and we call the creation of the terrain shader against render pass 1. We call the creation of the color 3D shader against render pass 1. I probably ought to like create a an enumeration or something for the render passes, but it is what it is. Again, same set of changes we've seen elsewhere. We got rid of the near far clip and FOV and projection matrix because we get those things from the view. We save off the width and height on resize, that's it. And then we've refactored this to take in, instead of the linear allocator, we take in the frame data, which has the linear allocator for the frame, and a pointer to the viewport. We save off the viewport, we save off the projection matrix. And then we also set the skybox data, right? So we'll see in the simple scene the other side of that where we actually bring that in. Down here a little bit further on the render, we got rid of the frame number and the render target index. Again, we have that in the frame data now. We no longer loop through the render passes. We don't need it to be that generic because we know how this is going to be working because it's the application's code, right? So the application determines this, so we can just do it as we know it's set up, right? So first thing we do is we bind the viewport. Then we do the skybox render pass. We've gone ahead and scoped this here. So we begin that render pass, do all the skybox stuff, right? So if we have a skybox, use the shader, set all the globals, the instance, and all of those, and then we draw, right? And then we end the render pass. And then we do the world render pass, which is render passes sub 1, right? And it's the same pattern as what was in there before, right? So none of this stuff has really changed. Just a few things with interfaces, right? When we call the global for the material system apply, we now pass the frame data render frame number and frame data draw index. Again, I'm probably going to go back and refactor this to just take the frame data and deal with it that way. I'm thinking, though, the reason that I might not have done that is because maybe we'd call it from somewhere that we don't have the frame number or the frame data, but we do have draw index and render frame number. I don't think that's going to be the case, though, so I think it'll be a safe change. Argix2, hey Travis, I'm not up to date with Kohi, so I'll just ask, are there plans for a scripting language? If yes, will it be Lua? Will it be another language or an in-house language? So what I'll say is this. We do have hot reloading of our game code right now. Although I think I've broken it with some of these changes, so I'll have to actually revisit that. We do have hot reloading of our C game library right now. So that gives us some of that need. the core of Kohi will not be supporting any sort of scripting language. So right now your scripting language basically is C. However, we are going for a plugin oriented architecture here. So if you wanted to make a scripting language, you could do that as a plugin. And I may do that as a plugin at some point. And so at that point, it could technically be any language, right? It could be Lua, it could be a language we make up, which would be terrible, unless we wanted an exercise in making a language, which might be interesting down the road. But yeah, usually proprietary scripting languages are rubbish. But yeah, I guess that's kind of the plan, right? Is like eventually maybe through a plugin, but not in the core. Yeah, for right now, C gives us everything we need. I'll gladly develop bindings for C#, kind of like Unity or Godot. Yeah, that will probably be the first direction I go in. Because that's the thing, like, you have to have bindings, right? And especially at this point where we have like so many interface changes and stuff still happening, you really don't want to try and make a scripting language at this point in development, right? You really want to have a lot of your features locked down, a lot of your interfaces locked down before you actually attempt that stuff. Or otherwise, every time you change an interface in here, you'll be breaking the scripting language. You really don't want to go down that road. Scripting languages aren't as valuable as you might think they are, actually. Everybody in the 90s and early 2000s thought scripting languages were the way to go. And if you ask any of those devs, they tell you absolutely not. That is not the way to go. I know John Carmack, specifically spoke against it, right? Like there was Quake C and all that stuff, and he's just like, yeah, that was a huge mistake. And he was so glad when he ripped it out of the id-Tech engine. Okay, so continuing on with this, we have a needs update check update. So it checks render frame number as well as the draw index. And then we sync down here. Again, it's kind of the same updates that we're seeing repeatedly, right? Another apply global change, this time for, let's see, the first one was terrains. This is for geometry. So again, it's the same set of changes. And then we have for the color shader at the bottom. And then the render pass end down here, we just changed the verbiage in here because we don't have render pass index. We just have a world pass, right? So it seems like there's a lot of code here, but a lot of these changes were actually repeated changes, right? So there's not a whole heck of a lot. The biggest thing was just adding the skybox and kind of combining it from that other view and getting rid of the other view. All right. So that is that. We kind of skipped the UI, and that's just because the UI doesn't have anything special added to it. It's literally just all those same interface changes that we've already seen, right? So we're just getting stuff from the view and the frame data as opposed to the stuff that's passed in, right? That's all it is, all the way down. And then of course the needs update changes as well, right? So not going to go into that any further because that is basically it. Render view skybox, as we see, these have been deleted, so no need to go over that. Here's the UI interface changes, right? Again, stuff we've already seen. Render view pick. Okay, so this render view pick is actually something I've turned off for right now. Because of the way that this one works, we're going to need some additional changes to actually make this work properly. But we're not actually using it anyways because we have proper raycast picking anyways. So I've gone ahead and turned this off, but I have made the interface changes to make it work. What I did was I went ahead and I added a to-do down here saying that this won't work as a single view because the application needs the ability to set the viewport difference in between. So if you remember, the render view pick does a pass on the world and then it does a pass on the UI all in the same view. And we can't do that anymore if we have split viewports like we do, right? So this view as one view won't actually work anymore. So we've disabled it now, put a to-do in here as to what we actually need to do to split it up. If we try to use it, we're going to get a fatal error that says, hey, don't do this, you dingus. Cut it out. So we need to refactor this guy. So I'm not really going to go too much into that right now. We just have implemented all the interface changes to make it build, but we have turned it off, right? So I hope that makes sense. Let's see. Zig has first class support for C, C++ libraries, so it would most likely work out of the box with Kohi. That would be kind of neat. That would be a neat thing to see. Once Kohi is at a usable state, I'll make some beta C# bindings. That'd be cool. Should be possible with minimal changes to Kohi, if any changes at all. Ideally, yeah. It should just work with exported functions, right? Just want to wait until the interface is at a good place for it. Yeah, exactly. C# can then call into the engine DLL easily, just like Testbed exe does. Yep, exactly. Yep. That's one of the things I love about C, right? It doesn't garble the output also, which can lead to some security issues if you're not careful too, right? But you don't have to like extern C like you would have to if you're using C++. Okay, so testbed main I'm going to not touch on right now. In fact, I'm going to skip this whole section. We've covered all of the views, so we're done with that. So see, we're almost done, folks. I'm going to touch on the renderer backend changes first, and then we'll kind of come back to the game code and we'll wrap this up, right? So, Vulkan backend received the same changes as the renderer front end, right? So we have this same for function, frame prepare, begin, end, and present, right? So this basically just mirrors what's on the front end, right? So that is the interface change there. Really quickly, the Vulkan renderer plugin main, we're just reassigning the function pointers here. So that's all that is. And then the biggest change is to the renderer backend, which honestly isn't all that much either. So the frame prepare replaces the backend frame begin, right? So it takes plugin and frame data just as that did before. The main change, like some of this stuff is formatting changes, like this is a formatting change. And that's, I think, actually all that changed with this. It's just the name and this formatting change, right? So this is a literal drop-in replacement for frame begin. Renderer begin goes ahead and grabs the context, the command buffer, which this is just the formatting change here, and then uses wait for fences, right? To make sure that the execution of the current frame is complete. And then the fence being free will allow this to move on, right? So this code hasn't changed, it's kind of been moved, right? And then we reset the command buffer and we begin the command buffer, so that hasn't changed either, right? So really the only thing we've added here is just this wait to make sure that it's actually ready to be used. And then, whoops, I left some comments in here, so I probably ought to get rid of them. But we removed all of this viewport logic, right? So this is just it commented out. I should probably go ahead and remove that. In fact, let's just do that now, shall we? So the only one we're going to set is the winding, right? We'll set that at the beginning, but otherwise, none of the rest of it needs to be set. Okay, so the frame end is no more, and that is basically now Vulkan renderer end. So we still get the command buffer, and then here we still do our images in flight check, right? We wait on that to be done doing the thing. And then we go ahead and we sync that up here, just as we did before. So like these changes are just formatting changes to get the stuff all in one line. So nothing has changed there. The only difference is when we are going to submit the queue for the command buffer to the queue for execution, we have to take into account what draw index we're on. If we are on the first draw index, right, or the first draw of the frame, then we are going to do as we did before. We're going to have one signal semaphore, which is going to be our queue complete semaphores, right? And then otherwise, we are not going to do that, right? And that's because we have one running right after the other, right? So we're basically banging this through the queue twice, right? And so likewise, down here, our wait semaphores are only going to be active on the first draw index call as well. So again, there's there, otherwise it's empty, right? That's the biggest change in there. This is a formatting change, and that's really it, right? That's all that's changed as far as that's concerned. Present basically just does what it says. It calls swap chain present, and then it goes ahead and where is it? Right? It goes ahead and does this and then just returns true, right? And a little further down, this is where we expand this a little bit. So in render pass begin, where we actually set up the render pass, right? The first thing that we do is we get a pointer to the active viewport, and that is how we set our render area. So you remember the render area used to have this stuff's cached. Now it just uses what the current viewport settings are for that, right? And that just determines what area of the frame buffer gets rendered to. And then the only other thing that we did was we added something in here in the shader use to store the bound shader in the context, right? Just because we actually need to know that in some cases, which was for the, I thought that was for the multiple pipeline thing. I could have swore we did that before, but maybe not. Anyway, that is all of the backend changes, right? So it kind of looked like a lot, but it's not, right? We mostly just move stuff around. Okay, so I think the last thing that we'll touch on before we get into the testbed main logic here is the simple scene, right? Because we did make a small change to this. So this, instead of taking the aspect ratio, now takes the viewport, right? Which you can calculate the aspect ratio off of that. So we take a pointer to the viewport, and then we also forward declared viewport, right? So that we don't have to actually have that included. In simple scene, we go ahead and include viewport H. We update this. We've removed the skybox view, or the sorry, not the view, the packet, right? So we've actually removed this from here, and instead we add it a little bit further down, right here, right? So all we do is we set in the world data skybox, we just set it to the scene skybox, right? If it exists, it'll use it. If it doesn't exist, it'll be a null pointer and we'll skip it. And then here in the frustum create, when we're actually creating the frustum to check for our frustum calling and all that, instead of using all this hard-coded crap that we had here before, we get all of that from the viewport. So it's much more dynamic that way. And then instead of passing in render view system packet build, instead of passing the frame allocator, we pass the viewport, right? So that is the simple scene changes, again, mostly interface changes. Testbed main C is where most of the changes have actually taken place. So we actually have the application prepare render packet. So this is the implementation of that new function that we have. So we have prepare render packet, and then we have render, right? So those steps have been separated. And then our last change is in C, the C file for that. So we've added our geometry 2D. We've added our viewport includes. We were finally able to get rid of our to-do, or get this from viewport, right? So this is in the game on drag event. Now we can just get a pointer to the world viewport, right? So as we're dragging and interacting with the gizmo, we can just use this now, right? Here's our change to ray from screen. So again, instead of grabbing the screen width and height, we're using the viewport rectangle and the viewport's projection instead of calculating that here, right? So that's that. And then this whole change actually looks like a lot of changes, but it's really not. So basically all we've done is we've wrapped all of this in a check. So we say, okay, let's get a pointer to the world viewport and then say only perform this action if we're in the primary viewport, which is actually the one on the right in this case, and we'll get to that in a second. So in this case, we say if the point is in a rect2D, so we take the XY, which is the mouse position. So this is the mouse drag begin event, right? So we say, is the X and Y within the viewport rect? If it is, go ahead and do all the stuff that we had here before. If not, don't do anything, right? And that's how we bound that mouse interaction to that viewport. And so the only other difference is obviously the change to our ray from screen now takes the viewport rectangle and the view projection. The other thing that we did here is when we come down here, so this is basically if we have a hit, right? So if we have a hit, we loop through those hits, we create a line from the camera position to wherever that hit was, and then we put a box right at the point of intersection. If we don't have any hits, then what we do is we basically just, instead of having a hit position, we actually just vector3, here it is, vector3 add from the ray position out 100, right? Magenta for non-hits, right? And a lot of this stuff was just shifted inwards, right? So it's the same code that was there before. The other thing that we did was we have deselection, which actually I think that was already in there too. That's just a formatting change. These are all just formatting changes, okay? So this one here is not a formatting change. So this is another place we are calculating projection matrix. So this is on the game mouse move. So this is basically for the hover interaction for the gizmo. So again, we get the viewport, we do a raycast, etc., right? Now, at the bottom, when we're initializing our application, right? After we've set up all of our arrays and all of our other stuff up here, right? We have our testbed state, our selection structure zeroed out. We set up our viewports, right? So we have three. We have our world viewport, which is sort of the view into the world that we had before. We have that UI viewport, and then we have the sort of test one that I have here, which I'm calling viewport rectangle 2. And all of these things are basically calculated based on the initial size of the window, and then there's some resize logic where we recalculate those viewports as we resize the window. So we'll get to that in a second. I just added some debug text here to bump this down another line, just to test the repositioning of the test text. Application render is now application prepare render packet. And so our packet view count between getting rid of the skybox packet and disabling the pick packet, we've gone from 5 to 3. So I have updated the testbed packet enum here to reflect that. I think that's actually, let's see, that's here, right? So skybox is gone. We left pick in there, but we're just not using it. So the indices of these have changed, right? Let's see. So yeah, this is where we were. Okay, so we set those up the same as before, just minus the skybox, and we've commented out the pick, right? Here is the simple scene populate render packet. We just passed the viewport here instead of the aspect ratio. And then if the simple scene is not loaded, we just make sure that the view has a pointer to the world viewport anyway, because it actually does still render. It doesn't actually draw anything, but it still needs a reference to a viewport regardless of whether or not its packet has been populated. So this is just sort of our hacky way to make sure that that happens. Packet build, again, that instead of passing the frame allocator, we just pass the frame data and the world viewport or the UI viewport. So we build those packets. And then here, we have all of our pick packet stuff. That's all commented out, right? So we basically just left it in there for reference, but it's commented out. Hey, bug creator. I'm not a bug creator. You're a bug creator, Nightlone. We're all bug creators. All right, so application render is probably another place where there were a lot of changes made. And I've got some stuff in here. I need to add some logging to this. But we basically have full control over the rendering cycle given to the application now. So when we call this, we can say render frame prepare. We can do anything additional that we need in between that. We can call render begin, which is going to begin our first queue. Or our first command buffer, rather. We go ahead and make sure that the, in fact, we probably shouldn't even, this should probably be moved up. I'm thinking. I'll have to try that and see. So we do all the same clock start stuff that we had before, but now we actually handle the packets individually. So instead of looping through them in the system like we were doing before, we've actually turned all that control over the application. So we basically start off the world render first. So we handle that one first. Then we do the editor world using that same packet data, right? And then we go ahead and we execute the current command buffer, right? So we render that first viewport and we say, okay, let's go ahead and commit this. And then we go ahead and we begin another command buffer. Oops, adds. Yeah, ad breaks are always fun, right? We've got about 35 seconds left. All right, we're back. Just wanted to make sure that we didn't miss that one, right? So as we were talking about before, we basically have this structure here where we begin a command buffer here, render these two packets, right? And then we end, and we commit that, right? Send it to the queue, and execute all of that. And then we begin the next command buffer, right? And in this case, we render the world again, but with a new viewport and camera. Or at least in this case, not a camera yet, but that's a to-do item, right? So we go ahead and we say we're going to get the world packet, the world view again. This time, though, we're going to set the projection matrix to the world viewport 2 projection matrix, and we're going to set the viewport pointer to the world viewport 2, right? And then we're going to call render on that again, sending the same packet this time, right? And then we'll go ahead and we will perform the UI packet to be drawn, right? And then at that point, we'll call end, which will submit that to be executed. And then we'll go ahead and present, right? So this gives us a lot more fine-tuned control over the way that the application fires off instructions to the render on how it works, right? You gave us ads. Yes, I gave you ads. Ads help me buy things for the stream, though. Okay. So that is the most important change. It's not necessarily the most verbose change, but that's the most important change to the flow of the application, right? The resize is also kind of important, right? So this is the application on resize that we're in now. So we basically just do a quick check to make sure that the size actually changed first off. And then we resize the viewports. So we do the world viewport first, which is on the right side. So we calculate that based on some padding. We're putting basically 20 pixel padding all the way around. And then we have the sort of half width of the entire window here. And we subtract 40 from that to give us 20 pixels padding on the other side. And basically what that does is it shoves that viewport over to the right side. Or I guess for you guys, it'll be this way, right? And then we do the UI viewport, which covers the whole screen, right? And then we do the world viewport 2, which is over on the left side of the screen. So for you guys, that'd be here, right? And we basically just put, again, 20 pixel padding all the way around that. So anytime we resize the window, which also happens when we create the window, our viewports will be in the correct position, right? The last bit of this is the configuration for the render views. The Tall Pants, thank you so much for the follow. I appreciate it. Welcome. So what we're dealing with here is we no longer have the skybox view. That is no longer a thing. It is now part of the world view. So the world view now has 2 render passes instead of just 1. So we set up that and we do the first render pass config as the skybox. Again, we don't have the render area, so we don't configure that anymore. So we set up all the same skybox stuff we had before. This basically just moved, right? In fact, you know what? This might actually make more sense for me to actually show you in the code. Let's do that. So, what was it? Configure render views. So, our world view basically now encapsulates the skybox pass. So the first pass is the skybox itself, which only has a color attachment, and this is why it has to be a separate pass, right? Because we don't want to render or reference the depth attachment, right? We only need to focus on the color attachment here. So this has to be a separate pass because of that. So we go ahead and create that render pass. And then here's the one for the world. So this is what was here before, just minus that sort of render area, because we don't have to do that anymore. We extract that from the viewport. So that is the change there. And then the other relevant change a little bit further down. This is editor temp stuff, UI view, right? That's all the same pretty much, minus the render area stuff. And then this is the pick pass, right? So I've commented this out as opposed to removing it because it has everything that we're going to need. We just have to split it into 2 views, right? So, or at least change the way that the view works internally so that we can call it once or twice with, you know, maybe different configs or something, and get them to do the passes individually. but yeah, that is pretty much all of it, right? And so with that, I believe that is the entire pull request. So we've done that. We've done that. Yep, that's the whole thing, right? So it's kind of a big one, right? Anyhow, time to melt my brain. DM me on Discord sometime. Yeah, for sure, I will. Nightloan, thanks for joining, man. I'll talk to you soon. All right, so with that, let me build debug, which that's another thing I've been working on, is kind of trying to improve my NeoVim experience here a little bit. And we'll go to VS Code to debug, and we'll run. And let me actually just change this over to terminal. Right? And so we can see now here that we have 2 viewports, right? So one, we can immediately see our editor gizmo here, but we do not see it over here. And the reason for that is Nightloan, I thought I made you a mod. You should be able to post Discord links. That's really weird. Huh, okay. Yeah, exclamation Discord definitely is the better way to do it. The reason being is because if you recall the way that we set it up in our application, the editor view is only executed against this primary viewport here on the left, right? Or on the right, rather. So when we load, we basically see that the viewports are working as we expect, right? So I can move the camera around, stuff like that, right? And they are relatively in sync. However, if I click over here on the left one, nothing happens, right? But if I click on the right one, I can select objects, right? So, I can move this around and it's updated in both viewports, right? So, this is basically the functionality that we've been trying to get to. I could have swore I made you... Huh, okay. Well, you're a mod now. So, yeah, so basically what we have now is, the ability to have multiple viewports. And you notice that our FPS did take a hit, right? And that's because we're rendering this entire scene twice. We don't have any optimizations in place whatsoever. And so, it's a little bit heavy. And in an ideal situation, we're not going to be rendering the same camera twice, right? Maybe we'll do this for VR or something, but, we don't have any optimizations in place whatsoever. We don't have any compression. We don't have any of that stuff, right? So at some point, we are definitely going to have to start optimizing some stuff and getting some of our speed back. But for now, that is what we're kind of dealing with, right? Well, those are new buttons, yes. Is this texture picking or ray picking? So this is ray picking. So if I actually move the camera over to the side, you can actually see all these ray casts came from, that was where the camera was. And then that's how they interacted with the objects, right? So, if I cast something out here to the sky and it doesn't actually hit anything, and then I cast one to the car and to the wall behind it, when I move off to the side, you'll see both, right? So the magenta one means we didn't hit anything. The yellow one means that we did hit something. And then we see both of the hit points here. And then there's also some logic in place to say whatever the first thing we hit was, we also want to pick that, right? So, here, for instance, if we have the car selected and we just select the Sponza behind it by clicking in, we can do that as well, right? And then we can move it around as well. Cool. Smudge, careful what you wish for. He might actually call your bluff on that. Okay. Why is the light's wireframe changing colors? That is a good question. because the light itself is actually changing colors. So if you look at it, the light is actually changing. So the box matches what the light is actually currently doing. It's dynamic. So, yeah, I see Nightlone actually deleted your message. Told you. Yeah, it's pretty cool, and especially when we have an editor set up and we are manipulating properties, it'll be a good way for us to sort of preview what that's going to look like. And we want to add some more debug shapes. Like eventually, I'd like to make you know, a spherical shape that maybe gives us the sort of inner and outer fall off radii of the lights and stuff like that. Anyway, so that is viewports for now. And what we're going to use this for is the editor. I probably am going to turn off the second viewport for right now in game code, but I am going to commit this exactly as I have it now first, so that you guys actually have access to exactly what we are looking at here on the stream. So I think I did have a couple of other changes though. Yes. Fixed issues found on stream. All right. Oh, what? What possible changes would I have up there that I don't have? I thought I already did this earlier. I did make some changes in main I forgot to mention. And apparently I never pulled them into this branch, so let me go over that really quickly. Nothing huge. I get ignored the compile flags text files because those are different per platform. I also fixed the build on Windows because I noticed there was some busted stuff there. Updated some of the Windows build processes. I renamed, I forgot to mention this, I renamed the INL files to H files just because it was screwing with my IntelliSense after some updates in NeoVim. So I finally just decided to bite the bullet and do that. I think that was it though. It's just those things. So that's what all these changes are, right? I don't think we have any merge conflicts either, which is awesome. Okay. So I should be able to now. There we go. Okay. So go to pull requests. And we will double check this. I think we should be good though. Yeah, it's the same number of files. Okay. So I'm going to put this into main. And delete the branch. All right, so all this stuff is now on the main branch. You guys have access to it. So yes, cool. Let me catch up on chat here. I was right-clicking the message and was like, no, why don't it work? Now test out the ban feature with that other guy. For camera icons, lights, etc. What do you mean, Tannen? Imposters? Do you mean, by imposters, do you mean billboards? See you later, Nightloan. Thank you for dropping in. Incidentally, the reason I just gave him mod privileges, by the way, is because he's also one of my Discord mods. So, he's an OG. Yeah, so billboards are not something I have implemented yet, but they are something for sure that we're going to need. And when I do that, then we'll have more than boxes. So the debug shapes are just there for like editor use and things like that. They do, for right now, show just as a box, right? But like I said, we're going to have a sort of a radius around these that's a little bit more descriptive of what they are. And then we'll obviously have some sort of icon that we'll be able to actually select that by. And we'll probably only show these boxes when it's selected, right? I'm just doing this to sort of make it a little bit more obvious as to what we're doing right now. I'm thinking probably I'll be able to leverage something similar as to what I did here for the gizmo, right? Because I've already kind of got like logic to draw this kind of thing. So I'm thinking I could probably just do that same thing. But yeah, I don't have billboard support yet. That is something I need to... Do I have that on the roadmap, actually? Because if it's not... It is not, so I'm going to add that. Let's put that ahead of particles, because particles technically use billboards. Billboards. So we've got that in there. Glad you called that out, because there's been like 3 or 4 times I've been meaning to add that to the roadmap, and I keep forgetting. All right. So right now we have we just have this system where we have the same camera being used for both viewports, which is cool and all that, but not really useful, right? If we wanted to do something like test out that our frustum culling was working or something, we would want the ability to have a second camera view, right? And we can't do that right now. And we really should be able to do that. And so what I'm thinking is there's a couple ways that we could implement this. We could couple cameras with viewports, which loosely makes sense, but not always. So we could have the viewport own the camera, where when we bind a viewport, we just get the stuff we need from the camera pointer on the viewport. Did I not? Okay, I did save the roadmap. I thought so. Maybe it took a second. So we could have the viewport own the camera, where it just has a pointer to a camera or something like that. We could have the camera have a reference to the viewport. Technically speaking, we could have both, but that gets kind of hairy. Or we could just have some sort of state object within the application that manages the two and knows which one to use where. And I'm tending to lead more towards that last one. Simply because we don't always know what the application is going to need to use in terms of viewports and cameras. And there may be one viewport that is shared across multiple cameras, right? Or one camera that maybe can use multiple viewports. You never know. And so you don't really want to enforce a 1-to-1 ratio in either direction. So I think the best way is going to be to just pass them separately and go that direction with it. Now, if we look at We're already in testbed main. If we look at our state, I thought we had. Don't we have camera create in here? Do we not? Camera view get. Here we go. Okay. So in application initialize, we're basically setting up this state world camera. And we're doing that by, and again, we have some to-dos here around this, right? We're doing that by calling the camera system get default, right? So the camera system just has one camera right now, and that's kind of what we're using everywhere. And I'll bet if I search camera system get default, so these are the camera system itself. See, like the render view editor world is using it. Actually, all the render views are using it, except for UI. And they shouldn't be, right? Like it should be passed to them. And then testbed main is using it twice. I mean, this one, there's really no reason it should be doing that. It should be pulling it from, we can fix this one right now. So this one should be state world camera, right? So that one's an easy fix. File has been changed since reading it. Really? Okay. Let's just let's reopen this and remake that change. So we want the address of state world camera. There. But camera system get default. We're using it once here. And really the issue is these views, right? These views, let's see, that's on packet build. I'm guessing that's also on packet build. And that one is, let's take a look and see where these are. So that's on registered. So this one, this is even worse actually, because this is actually setting it to, oh wait a minute, that's the test bed. So why won't you? Why won't you do the thing? Unknown type camera. Why is this freaking out? Render view world. What is going on with my imports now? Defines file not found. Oh, is my... Did my testbed lib... Oh, it didn't generate a... compile flags file. Oh, because I switched branches, it probably didn't have it in main. That's why. Why are you doing that? Build debug. Incompatible pointer types. Oh. Is that really what screwed up the entire thing? So... State world camera. Construct camera. How did that not get caught before? Aren't we including... Okay. Let me do it this way then. Struct camera. Struct camera. Although I think camera system should give us that though. We shouldn't actually have to do that. Why is this bleating then? Let me do a clean. I'm gonna build debug. Did I break master? I must have had a typo in there or something somewhere. All right. So let's initialize. Where was I? I guess I hadn't saved. Oh wait, that's... Just thinking about the design choice of only allowing one directional light because it's meant to be the sun. What if the game is Tatooine? That's a good point, I suppose. I guess the... Well, I guess theoretically you could just add them together like you do on directional or point lights. In theory, there's no reason we couldn't do that. I just chose not to. Theoretically, it's up to the scene, right? So we could just change the scene to support more than one. Lads. I might have to change the ad screen to reflect lads somehow. Bad timing for this ad. Yeah, I know. All right, so got another 15 seconds on ads. All right, yeah, that was kind of crappy timing on ads. because we're basically done for the night, but I'll run a couple minutes over just to make up for it. So I think what we were doing was camera system get default. And so basically anywhere where these are being passed this way, we basically just need to, so that one's on packet build. This one is on register, which is even worse because that's part of the data, which is the, you know, sort of internal data. So we don't want that either. Let's see what this other one is. So the pick one, that kind of makes sense as well. The editor is also unregistered. So when we're standing up these views, it's doing this, which is not good. So we basically just are going to need to remove those from there, and let's see. We don't want to have them be part of the frame data. They should probably be maybe part of this data structure. Maybe we should pass them along with the viewport, right? Maybe we should pass it right next to the viewport on all these views. I think that's probably what we're going to do. So I think in tomorrow's stream, we're going to work on multi-camera support. We might make that change to the material system to take in frame data. And then in views, we're going to pass a camera. And I'm just taking notes so I don't forget that tomorrow. And so that should allow us to at least have different cameras per view. And then maybe what we can also do is experiment with like an orthographic view in that one perspective. And I don't know, maybe we can come up with like a wireframe view or something, right? Maybe add wireframe functionality. Wireframe. Because we're going to need that as well, probably. We're going to need the ability to toggle to wireframe, which is also going to be another potential pipeline thing. So we'll see how that works. It may wind up being better to start standing up and tearing down pipelines in some cases, but we'll see. I think, though, we've done pretty good for tonight. We have viewports done and dusted pretty much, right? So the next thing we're going to work on is some camera stuff, and then I think after that we might actually start looking at some UI controls and maybe implementing some of those, just some basic ones. And after that's done, I'm thinking we can probably start maybe thinking about standing up our editor application. Get that scaffolded so we can actually get out of Testbed and actually start building the proper editor. We're getting close, folks. We're getting close. So the editor is probably going to be where we're going to spend quite a few streams worth of content, honestly. But yeah, there's just a couple more things I want to get in. And I'm going to have another look at the roadmap to see if there's anything else I should get in before we actually start the UI work for the editor. How long do your stream sessions usually go? Right now, around 2 to 2.5 hours. I'm not really able to stream longer than that because I do have a full-time job. So I'm only able to do this a couple nights a week for a couple of hours, which is one of the reasons that I don't do all of it on camera anymore. I have to do some of it off camera because otherwise we'll never wind up being able to move forward, right? So with all that said, I do want to point out that there is a website for Kohi. So there's kohiengine.com. So if we drag this over here, this has basically all the information about the project that's out there. YouTube, Twitch links, link to the GitHub, Patreon, Discord, all that good stuff. Join the Discord. I think there's about 600-ish people on there right now. I actually haven't looked in a little bit. Let me see if it will give me that number. I forget exactly where that is, actually. Anyway, yeah, I think there's like 600 plus people on there now, so it's growing definitely. But yeah, everything that we're doing is open source, Apache 2.0 licensed, so it's all here on the GitHub repo. We have this. We have a small wiki that I'm working on putting together with a roadmap, right? So it's not the most fancy thing, but I do have a lot of stuff listed in here. Stuff that is upcoming, stuff that's to do, as well as what we've already done, right? So these are all the systems we've already put in place. And then the other thing is we do have API documentation. This is auto-generated, so every time I push to main, this should go ahead and update. So this is for the core engine only for right now, but if you look at DRA, for example, it gives you auto-generated documentation on all of the APIs for that, right? So yeah, that is pretty much that. I'll drop a Discord link here too. So that is our Discord server if you want to join that. All of these videos are also uploaded and archived to YouTube. So the link to my YouTube channel is there. Feel free to go over there and give a follow there as well, so that you can watch all of the other videos and the other stuff I have on my YouTube channel. But yeah, I think that's where I'm going to wrap it up tonight. Thank you guys so much for joining me. It's been a lot of fun. We accomplished a lot of stuff tonight. And we should be back tomorrow night around the same time, 9 p.m. Eastern Daylight Time. And we're going to go ahead and implement this other stuff that I mentioned here earlier and get that in. So let me see who is online. Cosmoite, thank you for the follow. Let me see who I can raid. So I'm going to raid a favorite of mine, which is a channel called Ferret Software. It is a channel that's basically you can watch ferrets on screen, and the owner of the channel is Pirate Software. He's another game dev here on Twitch. He is basically running a bit of a ferret rescue at this point. He's got I think 16 ferrets now that have been rescued from various bad situations, or surrendered, or they were previously used for lab testing, things like that. And he's giving them a good home with lots of attention, lots of love, and good food and stuff like that. And all of the ad revenue from the Twitch stream is actually going to pay for their food, their medical expenses, things like that. I think it's a really good cause. Yeah, so with that, I'm going to go ahead and raid that channel. And thank you guys so much for being here, and I will see you guys on the next stream. See ya.